So, looking at solving first, yesterday when we factored all of our problems, we set them equivalent to its multiplied form. So x squared minus 12x plus 27 equals whatever the two factors were. But today, I've set it equal to 0. We're going to solve. So there's a difference between solving and between just factoring. So pay attention to the directions. When it says factor, you just have to factor. When solve, you actually have one or two answers. So we're solving quadratics. Quadratics, remember, ax squared plus bx plus c. And now the important part today is that we make sure that before we solve anything, it equals 0. Okay? So, number 1, is it set equal to 0? Yes. You look down at the practice. Is number 2 set equal to 0? 3, 4, 5.
No.
No. Okay, so the first step before you start factoring out a GCF or anything is that you need to set it equal to 0. So how can I manipulate this equation? Minus 2. The back. Okay, so 4x squared plus 7x minus 2 equals 0. Yes.
Oh, no.
Wait,
Okay.
why is there minus 2?
Because I subtracted 2 from both sides in order to make it.
Oh, okay.
Okay. Stop. Thank you. Alright. So that's the first step. I'm not going to solve this one further yet. We're going to go back up to number 1. So once you realize you set it equal to 0, you need to start factoring. So the same exact steps as yesterday. When I factor x squared minus 12x plus 27, can I factor out a GCF first? No. So what is a times c? 27. And we need factors of 27 that have a sum of what? Negative 12. So what needs to be true about my factors?
One has to be negative.
They
Both
have to be negative. So negative 27 and negative 1?
9 and negative 3.
Negative 9 and what in the world?
That's funny.
Negative 9 and negative 3. Everybody seems to be in agreement there. Yes? Okay. So let's set up our area model. Top left, x squared, bottom right. Diagonals,
Negative 9x and negative 3x.
okay. So now let's factor that out. Remember, since both values were negative, just go ahead and pull those negatives out to start. X squared and 3x. X. 9x and 27. Good. So then the left-hand side has to be
X and 3.
and negative 3. Good. So everything's still the same. Now when you're done, x minus 3 times x minus 9 is equal to 0.
Why?
Because it was equal to 0 at the beginning.
Okay.
So we've got it set equal to 0. When you go to solve, you're going to take the first factor and set it equal to 0 and solve it. So how would I solve for x? Add 3. X equals 3. And you're going to do the same for the second factor. So x minus 9 equals 0.
X equal to 9.
Add 9, x equals 9. Those are your answers.
Why do we need these?
I'm going to explain. So realistically, you set that function equal to 0, and what you're solving for are the zeros of the function. What else? What else can I call zeros? X intercepts. So, so x intercepts. If I graph these values on my coordinate plane, x equals 3 and x equals 9, they're going to match up with my parabola. So what I need you to do is in your calculator, go to the graph and enter in x squared minus 12x plus 27. Where am I getting x squared minus 12x plus 27? That's what we started with. That is before we factored it. So put it into the graph and pull up the table for me. So when you're looking at the table, what is y when x is 2, or f of x when x is 2?
7.
7. 3?
0.
0. Right? Yeah, you know I'm looking at you. All right. 7, 0. Is this meaningful to me at all? No.
Yes. It's the x.
Right here. Okay, what about 4?
-5.
5.
-8.
6.
-9.
7.
-8.
8.
-5.
9.
0.
Bingo. Okay, and 10.
7.
7. Do you start to see values repeat?
Yes.
Yeah. They go down and down and down. They hit 6, and then they go back up. So that forms your parabola. If I graph these, there is your parabola. And where does it cross the x-axis? 3 and 9, which is exactly what you found by factoring and solving. All right, so let's answer these questions. What did the answers from step 2 represent? The x-intercepts. Y'all don't have to be afraid to answer the questions. It's just the extra conversation that I don't make. Why?
Because it's set to 0.
Very good. It's set to 0. If I have a linear function, y equals x minus 3, when we did linear functions, how did you find the x-intercepts or zeros of those? You replaced y with 0. Well, in this function, you had f of x, and what got replaced?
0.
F of x, which is the same as
0.
became 0. So you did the exact same thing, because f of x, or y, was set equal to 0. And that's how you find x-intercepts. It just so happens that with quadratics, you can have more than one 0. There's scenarios with more than one, there's scenarios with one, there's scenarios with none. Just like, well, linear doesn't have two. Linear only has. Okay, how do y'all feel about that so far? Good. Okay, so number 2, k squared minus 36 equals 0. Can I factor out a GCF?
No.
No. A times c? Negative 36. I need factors of negative 36 that have a sum of 0. If there is no center term, that means that b is equivalent to 0. Good. What are the factors of negative 36 that equal 0? Negative 6. Very good. So let's set up our area model. Top left,
K squared.
k squared. I used x in my table. Don't worry about it. And bottom right,
-36.
and your diagonals. If you use x instead of k on a test and your variable's off, I'm not going to count off. Okay? We're so used to seeing x everywhere, it's not a big deal. All right, so let's factor out k squared and 6k. What can you pull from those?
6 -6.
plus k.
Oh, yeah.
Okay, negative 6k and negative 36. And then the left-hand side, k plus 6. So, k plus 6 times k minus 6 equals what? 0. So your solutions are that would mean that if I graphed it, my zeros are here. Okay? Then you can check using your graph. Now, will they always be whole numbers? No. So your table will not always work, but you can identify looking at your graph if you're in the right vicinity or not. Yes?
So, how do you find like the curve itself, like where
Where the vertex and stuff is?
like for example, like on
We're going to talk more about that in the upcoming weeks. Right now, we're just trying to find the zeros. All right. Let's look at 5. We already did something with 5, right? What did we already do to 5?
Made to 0.
I had to set it equal to 0, so I had to do some shifting. But now, let's start our regular steps. Is there a GCF to factor out?
No.
Okay, what's A times C?
Negative 8.
Factors of negative 8 that have a sum of?
7.
7. 8 and negative 1. Good. Top left,
4x.
bottom right,
-2.
diagonals.
8x and
Okay. So let's get those factors. 4x squared and x. X. 8x and negative 2. Positive 2. 4x squared and 8x. Negative x and negative 2. Very good.
That's good.
So, 4x minus 1 times x plus 2 equals what?
0.
0. Okay, so now we have 4x minus 1 equals 0, and x plus 2 equals 0. Add 1, divide by 4, what is this x? 1, 4. What is the second one? Negative 2. So if I pulled up a table on my calculator, would it show me both of these zeros? What are the x values on your tables on your calculator? Well, this is a decimal. Do I see decimals on my calculator? No. The table will only pull up whole values. So if you try to cheat the system and go straight to your calculator, you'll get negative 2, and you'll get half your points off because there is another 0. It's just not a whole number. So you guys have to go through the whole step. You can't just cheat through on your calculator. Okay? All right. So that is solving. Now, flip to the front. We are going to factor, which we already know how to do using the area model. Now, I'm going to not use the area model. I'm going to give you guys an alternate way to solve. If you are comfortable with the area model and you choose to use the area model going forward, you can, right? I'm not telling you that the area model is wrong. I'm not telling you you can't use it. I'm giving you another way. Some people like this way, some people like the other. All right? So, looking through our steps, let's see what's changed. Factor out the GCF. Has that changed?
No.
Nope, same. A times C? Nope. Factors of A, C, whose sum is B?
Nope.
Nope. Create two binomials.
Yes.
Okay, so everything up to here is exactly the same. You're just changing the point where you get to the area model. So, if we look at number 1, 2x squared plus 11x plus 15.
No GCF.
No GCF. Okay, well, what's A times C?
30.
30. I need factors of 30 that have a sum of 11. 6 and 5. Everybody agree with that? Okay. So here's where things are different. I'm going to set two binomials, and I'm going to start them both with my a value times x. So 2x times 2x. Now, what's wrong with that? It equals 4x squared. It does not equal 2x squared. And then I'm going to put in these factors that I just found. So plus 6 and plus 5. Does anybody have a problem with that?
No.
No?
Yes.
It does not equal 15. So there's something that has to still be done. At the beginning, you multiplied a times c. You multiplied two values within the same side of an equation. That's actually not an equation, so an expression. So realistically, what's our normal rule with math? If you do something to one side, you have to do it together. There is no other side, so I've kind of broken a fundamental rule. I've multiplied within. So I need to get rid of what I multiplied. So I need to factor my a value back out and throw it away. I'm not factoring it out to the front because I don't need it. I need to factor the 2 back out. So look at your 2 factors. Which one will both terms divide by 2? 2x plus 6. So I'm going to divide that by 2 to get that a value out. When I divide it by 2, what's left?
X plus 6.
X plus 3.
3.
And I leave the second one alone. Now, if I multiplied it, do I get 2x squared? Do I get 15? Yes. Bless you. That is it. Okay? Let's look at number 3. Did I factor out a GCF?
No. Yes. Yes.
4.
6. No, 4.
4. Can't get an 8, 6 and 8. 4, 6. Okay. What's left?
2x.
Oh. Y'all almost threw me off. I was trusting you. I almost read 4. Okay, so now, using what you have inside those parentheses, but remember at the end, that 4 is still there because the 4 is meaningful to us, right? In order to get back to where we started. Okay, so,
-8.
thank you. -8 that has a sum of?
-6.
-8 and +1. So, now, this has been a confusing piece for my last couple of classes. These both end up with 2 in your factors. It's not a common rule that it's just 2. It's whatever the a value is. So if my a was 3, I would have started with 3x and 3x. Okay? It's not always 2. But, what do we need to throw back away? 2. Because what is my a value? 2. A value is just 2. So I need to divide one of these factors by 2. Which one? The first one. And so, when I rewrite it, the 4 is still there, but I throw, what do I have left here? And you're done. Yep, same answer as the area model. You just need to be really careful that you factor your a value back out and throw it away. Alright, let's look at number 4, and then I'll let you guys go off on your own. Can I factor out a GCF?
Nope.
Nope. A times C.
-90.
-90 that has a sum of?
30. -5.
Okay, so -90 and 1?
Number 4.
Nope. -45 and 2? Nope. -30 and 3? Nope. Does 4 work? Okay. 5 and -18? Nope. 6 and -15? Nope. negative 10 and 9.
Yes.
No, that's negative 1. I need negative 5.
Oh, not bad.
That's all good. Great. Nothing worked.
It's not hot.
Yes. Okay. Now, be really careful. I went through all of the factors of negative 90. If you have a large number, this list could get extensive. So make sure you test things out on your calculator. Because when we were simplifying radicals, I don't know if it was any specific class, I had a few people that told me that 121 was prime. It's not. It's 11 and 11. It's actually a perfect square. So be really careful, test things out on your calculator, okay? Before you jump to does not factor. Don't just jump here after you try 4 things. Make sure that you've used all of your avenues. Also, does not factor is not the same thing as no solution. There is a solution to this. It's just complex. It's a root. So, do not put no solution because there is a solution. Everybody feel pretty comfortable?
Yeah.
Okay, at this point you probably have a preference of area model versus factoring A out at the end. So, whatever way you like, continue with it. Alright? So, you're going to factor 2, 5, and 6, and then on the back you have to finish out solving 3, 4, 6, and 7. So you guys have a few problems to do. It is not homework, it is classwork. If you choose to not do it right now, then I will assign it as homework. Don't waste time. Okay?